I'm never really sure when we are live, but it's counting up, so we should be live. Okay, welcome. This is a new Pi4J live stream, and this one comes with a very specific smell, smoked food, and fresh Java code. Today I'm joined by Matti from the Vaadin team.
Hello.
And together we're going to talk about something that started as a Raspberry Pi side project on his side and turned into a full-blown IoT application because he has built a smoker controller. So yes, an actual barbecue smoker with Pi4J, Vaadin for the UI, and Quarkus as the backend, or how do you call it in a Vaadin application?
Well, it's an application or a server or whatever.
Yeah. So it provides the Vaadin UI and then a lot of functionality inside of it. So we can now officially say that Pi4J version 4 has been smoke tested in production, but then literally. So Matti is not only a Vaadin expert, he's also been tinkering with hardware, thermometers, servo motors, and even sunset time-lapse systems on a Raspberry Pi. So we can expect a conversation that goes from low-level Java APIs all the way to flames, temperatures, and camera angles. So grab yourself a coffee or whatever you pair with barbecuing, and let's get into it. So Matti, thank you for joining. Thank you also for being a supporter of the Pi4J project, as you helped me already a few times to improve my demos.
Yeah, and I really hope that I can actually make some actual contribution in the future as well. I have a couple of ideas how to improve now with the experiences from this project, for example.
Okay, we're going to show in a few moments what you have been building. First, I want to go to the Pi4J website. So for people who are new to this project, the idea of Pi4J is to provide a friendly object-oriented I/O API and implementation libraries for Java programmers to access the full I/O capabilities of the Raspberry Pi platform. So translated into normal words, we just want to make it easy with Pi4J that you can control LEDs, read temperatures and other sensor values from these 40 pins on the Raspberry Pi. And actually, what we will also try to demonstrate this year is that you can do this on other brands of boards which also have these I/O pins. And we can do that because some time ago we released, let me check here, when did we do that? Well, almost 1 month ago, we released version 4, and version 4 is a new version of Pi4J based on Java version 25. And that means that we can make use of the FFM API, the foreign function and memory API, which was added to Java 22. And this is a whole new approach within Java to interact with native libraries, access the memory directly. The goal is to interact with other existing libraries, for instance, will be very important in everything related to AI and LLMs, so that you can use existing C libraries from a Java program. But that's also what we need in Pi4J, is that we can call the APIs to interact with these pins. If you want to know more about this, I have an interview with Nick Grichenko, who actually made the FFM implementation in Pi4J. We also had a live stream 2 weeks ago, so the link is on the Pi4J website. The video is too, but I will also add it below in the show notes in the description of this live stream when it's over. So here you can read more about the FFM API, how it works with Pi4J, some performance tests, and so on and so on. So this is a bit of the background info also for this video, because Matti, you're also using this version 4 in your application, right?
Yes, I'm always using the latest and greatest. And when I was building this, I was using the snapshot version that I built locally, and then now it's updated to the 0.0 version.
By the way, if people are interested in using the greatest and latest, is it download? Yeah, download. The snapshot repository builds are actually available in the snapshot Maven repository. So
yeah, in the new central repository.
Yeah. So if you use this to your POM file, and say that snapshots are enabled, then you can actually use, for instance, 4.1.0 minus snapshot. There are no improvements yet in there. We're really cleaning up from 4.0.0. But if you want to use the latest and greatest, as you say, you don't need to build it yourself. You can grab it from the Maven repository. Okay.
Unless you want to make your own changes into it.
Which we, of course, encourage. This is an open source community project. So we, of course, ask you to contribute if you find improvements that you can do. And if you want to get started, if this is really new to you, then check the JBang example. So JBang is a way to have single file applications with dependencies. Like, for instance, toggle a LED or read the state of a button in a single Java file with these extra lines on top. You actually instruct JBang to download Pi4J. Oh, I need to update this documentation. I see still using version 2. Okay, that's something new for me. But actually, the JBang examples themselves, if you go to the sources, they are updated. And there you see how you can use this. And actually, this was a remark you made, Matti, before we started this stream. People who used Pi4J before, actually the code didn't change. How you interact with GPIOs is just that instead of the PyGPIO plugin, you use the FFM plugin. And under the hood, it will use this new way of talking to the GPIOs, but you don't need to change anything in your code.
Yeah, the actual API is exactly the same.
Yeah.
By the way, related to the JBang, I could actually mention that I really like the approach, especially if you play around with these tiny little computers that I have tried. So I've been trying to keep mostly on the Raspberry Pi Zero, so that have like very limited memory. So then you don't want to do your full Java development on the Pi itself, but with JBang you can still execute those. So it will just download the dependencies and just run the actual Java code, and you don't need to do the full packaging and executing Maven and so on.
Fully agree, and that's also why I've been focusing on that approach. So if you go to this Pi4J JBang repository on GitHub, then you will see that you have all these examples, and the one that I'm just showing is this RGB LED. You see here it's updated to the 4.0.0 version. So here it's using the FFM plugin, and here it's using toggling RGB LEDs. So one RGB LED which has red, green, blue, so you can change the colors there. So that's an example, but there's way more here. So also Cyril actually is not I2C. It's like putting the weather forecast on an LCD display. I have such a display. I can show you. So for instance, here with this CrowPi, you have such a display in the middle, and there you can, for instance, put the weather forecast on a 2-row display with 16 characters. That's an example which is here. And I like especially this example because this is really something we as Java developers are used to do, calling an API, parsing the data that we get back from it, and then display it in some way or handle it in some way. And here it's using the Jackson library to parse the JSON weather forecast. I think it's even in the source code. Here, this is what we get back from this weather API. This is just JSON. We know how to handle this. So this is an example with a lot of Java code that we use in our daily job. And then somewhere you have a little bit of Pi4J to actually control a display and put a weather forecast on that display. So this is a nice example how you can combine your Java knowledge with electronics. And that's exactly what you have done. So let me get this back from the screen. This Smoker project, tell me more about it.
Yeah, if it would be a bit more warmer weather, I would actually show it to you live. It's actually on the yard somewhere there. Yeah, so that's my sauna, and next to it, okay, this is actually reversed, but there you can maybe see a bit of it.
we have to explain. You live in Finland, right?
Yeah. So the temperature is currently 3 degrees plus degrees. So there is no snow anymore, but there is some ice on the sea.
I really like the view you have there. Is that your home office?
Oh yeah. This is usually where I work. I have basically relocated here. It's like 45 1-hour drive to our office, but this has at least as good network connection as our office, and the views are much better. And well, the thing that I'm missing is sometimes the lunch company. So there is not too many restaurants on this small island. So
and the chat at the coffee machine. That's also something you're missing, probably.
Yes, absolutely. Those are the best parts of the like the
office work,
office life. Yeah. Can you show my screen a bit? So maybe I can just
this one.
Yeah. So this is the photo of my smoker. So it's not a tiny smoker device. You can see one of those in the right. That was my original one when we moved over here. But then I wanted to have a bigger one where I can put some, for example, some venison legs and smoke those, and also if you get a lot of fish, you can stuff like several kilos of fish at the same time to do this one. But because it's a big one and completely manual, adjusting the temperature is always kind of a bit hard. So it's currently functioning so that you have this small vent right here, and that basically controls how much airflow is going into the woods that are burning here in the bottom part. And then the heat and smoke goes upwards to this actual like food chamber, and then you get your smoked food. But this is what I wanted to basically automate originally. So I wanted to control this vent automatically. And then I was discussing this with my brother, who actually works on a nuclear plants. So he has a lot of ideas about regulation technology. And then after a couple of iterations, it turned into this. So this is now, maybe you can actually switch into the to my iPhone camera. So yep. So this is now the automation. It's not put into the actual smoker yet, because I need at least +5 degrees so that I can glue it through the brick wall. But here is the regulation technology, the high-tech Raspberry Pi, and then there is a couple of chips. There is one MOSFET transistor, and then it controls these two devices. So there you can see what is a microservo, and that is connected with this piece of thin wire to an old change or carburetor. So if you know how it works, there is basically a flap that controls the air intake in a chainsaw. But because this pipe that is going next to the smoker, it's quite thin. So that's why I wanted to have a turbo option here. So I have a fan, and I'm controlling that also through the same Raspberry Pi. And everything is, of course, powered by a battery, so that if somebody cuts off the electricity, then my smoking doesn't care. My food is still served.
Yeah, the food is not lost. I love the fact that it's built into a wine kiss box.
Oh yeah. That was the hard part, to empty the Amarone bottle. So yeah, and I have of course, like, input is basically the temperature. So I have this is the main temperature thing that is going to be installed to the actual firebox. So this is a thermocouple K style of thermometer, so that you can basically put it into a fire and it's going to be okay. And then this chip is connected to that, so that's the thermocouple. I think it's like amplifier, and that actually contains one chip of thermometers as well. So it's kind of a reference number, and then I have the old thermometers that I had like in the past as well. So this is another device, but same model that I have like bolted into the door, and it's actually currently connected now. It shows 20 degrees because it's here in the room temperature, but usually this goes through the door, and there I can get the reading from the food chamber, and then I have these meat thermometers, or what I can use as a meat or for fish. So 2 are connected to this device, and then these 2 are quite high tech. These are meter devices, and these are actually not connected directly to the system, but they are for these I get the data through the cloud API. Okay. I actually did a Java library to parse the Bluetooth data also from these, but it succeeded only from this older model, and the newer model that was too hard for me to do the reverse engineering. So then I just I thought that, well, I have a very good Wi-Fi on the yard, so I can also use that cloud API instead. So I'm just connecting to their REST endpoint and getting the readings from there. And then I have a lot of data, and I have APIs through the Pi4J and Raspberry Pi to these actuators, and then I can control the temperature and for example create estimates that when my food will be ready.
Maybe a stupid question is why would you do this with Java, but you're a developer at Vaadin? I think that's also one of the main reasons.
Yes, that's that. Well, yeah, Java is my native language. That's what I have been doing for the as my bread and butter for the last 20 years. So it's a very, very natural choice. So I probably wouldn't have started this project if I didn't know that I can use my actual programming language to get things done. Otherwise, this would have been too risky, and I too much problems. But now when I have been able to do pretty much everything in Java, or I would say practically everything in Java here, it's so much easier to approach this system.
Yeah, and that's actually the goal of the Pi4J project. If you're an experienced Java developer or you want to experiment with Java, you don't need to worry about the low-level stuff. How do I talk? How do I turn on or let? How do I read the sensors? How do I read the temperature from a sensor? Stuff like that. There's a lot of example code and a lot of the underlying things are handled by the Pi4J library. So you can really focus on what we as Java developers are good at is handling the business logic. And in your case, it's the business logic for your smoker.
Yeah. That's the harder part, like creating the controlling logic and creating all the displays and creating all the views where I show the temperatures and so on. So that's kind of the difficult part.
Okay. So we had the hardware, we have seen your setup. Now, how do you visualize this? That's where we come into the Quarkus and Vaadin part.
Yeah, let me show it to you through the let me show with the desktop version first. So this is now coming from the actual device. I have it there on the Pi, and this is the application. This is one of those views. This is listing all those thermometers that I have connected there. There is one that is not currently connected, so it's the Bluetooth thermometer that has only like one probe attached at the moment. Then there is these meters, and then this one is that goes through the door, and then these amperage sensors are they are from these same devices. So there is one sensor here and one on the tip that goes to the meat. And then this is the thermocouple K probe, and this is the chip, which is basically in the thermocouple amplifier. And then I have the actuators. So I will actually show you also the video. Maybe you can set up a visualization here, because this is going to be very fun. So now if I adjust the throttle here in the chart, you can see how it actually moves in the there. And now if I put it to the 0, it moves again. And now if I click on the rotor, the blower, I'm not sure if you can hear it, but that is now moving. Yeah. So this is now using like a software pulse width modulation. So it's using very long like a working cycle. So it's using I think it's 10 seconds working cycle, and now it's at 50%. But if I put it to the 100%, it will be turning all the time. And of course, the best part here. The best part here is, of course, if I open now the throttle, you can see the flames growing in the visualization. And now if I shut down the throttle, now they go off. So I built this tiny little Vaadin widget here using SVG and Java API, and now I can just like get the kind of estimated flames and show them in the Java UI. So now I can get some feedback if I happen to be away from the smoker. If I go for a fishing, then I can adjust it from my mobile phone.
So you go fishing while your previous fish is being smoked, and you can still control it.
Exactly, yes.
Okay.
And then this is kind of the home screen. That this is what I have been using as an entry point here. I have a system monitor here because this is currently also under development, and my hardware is the cheapest Raspberry Pi you can get. So it has only 500 megs, and some megabytes are also going for the graphics card. So not everything is even available. So that's why I have the system monitor there, and then I have like an overview of the temperature. So one from the door, then the meat temperature. It's a bit warmer than my room temperature at the moment because they are in a cup of water that was heated in a microwave before the session. So it's still more than 20 degrees. Yeah. And then I have built an automation. So on this system, I can basically set up the target temperature and then hit start, and then the AI called if clauses and algorithms. So an actual, not an LLM, like real predictable Java code does the regulation of the actuators.
Okay.
And
I'm impressed
then
with this interface.
Yeah. Oh, and the food dashboard. So this is what you will be looking when here you can see actually how the water temperature in my cup has been going down. So usually these when you are smoking, these goes up. I already saw that last week when I was doing some beta testing. So I had this same device. It was still not connected to the smoker, but I had some actual food in the smoker. So I was getting data from the Bluetooth sensors. So then I was already seeing that this view actually works. And then there is a simulation view. So this is what I have been using for a couple of hours when I have been adjusting the automation logic. So this is something that I can, and I have actually mostly done it so that I will just run the Quarkus application on my local computer, and then I have it. I test it here. So if I run it here on the workstation, it starts up. It works perfectly, but it says that there is no hardware, and then it's simulating some kind of numbers for the regulation for the thermometers, and then I can use the simulation here. So if I, for example, click start here, it opens the throttle automatically. This is now not on the device, but this is on my local workstation. And then I can kind of cheat how the chamber temperature is going. So if now you can see that it turned on the blower as well. But now if the temperature starts to rise too fast, it will be putting the blower off. it takes a bit of time because there is in the algorithms there is like slowness, and you can actually increase it here. But now it's here that okay, there is too much rise on the temperature, so it completely halted automatically the throttle and the blower. And you can also use this simulation on the actual device. So this is now on the smoker.local, so in my local network in this one box, and I could run it here as well, the simulation, and then I can try to heat up the one thermometer and see how the system behaves.
Okay. By the way, is all this available as open source on GitHub?
Absolutely, yes. So the link is here. We will probably put it in the description of the video later on. But like pretty much all of my applications that I write as a Vaadin DevRel, then it's open source, and I think this one is Apache 2 license. Okay. So you can in theory replicate the system, and I will be very happy if somebody wants to do that, and I will be very happy to help them. But I'm a bit afraid that this will be the only unique installation. But I think what's at least as interesting for me or like inspiring for me, if somebody gets inspired based on this project, forks it, creates another system, and uses that then.
Yeah. Maybe you end up with some kind of library of algorithms for specific smokers and specific food.
Yeah. Actually, if we look into the building blocks, let me show this project from the. Okay, this is now showing only the actual Quarkus application. But if I will go here and so if you look at how I have structured this, so all of these things that I have done, for example, this NCP 9600, this is the thermometer chip that is in there, the thermometer amplifier, as they call it, and there that's a separate Maven module, and inside the sources there is a test application that you can run. So if you have a similar or similar-ish device, this library probably helps you a lot. And in the Java code, this is very, very simple code. There is a lot of classes, yes, but in like behind the scene, this is now depending on Raspberry Pi or the Pi4J project, and all you need is to build your own version of this locally. And then use that. I guess in the future we could incorporate this kind of projects maybe to the Pi4J project as well. So I think it would be nice if there would be kind of ready-made drivers available for different devices.
Yeah, that's actually something which is indeed ongoing. Is let me see if I can show it again. Where is my screen here? So if we go back to the GitHub of Pi4J, and it's called drivers, I think. So this is
I think I spotted that. Yes.
Yeah, indeed. So this is drivers for various electronic components using the Pi4J library. So it's not released yet. We were planning to do that this month, or probably next month. But the idea is here to have a list of. I'm not sure if they are specified somewhere. A list of implementations for specific drivers that used to be part of the Pi4J library itself in version 1. And actually, it was the reason why version 1 became almost impossible to maintain. There was a too tight coupling between the very low-level code to interact with the GPIOs and then all these implementations. And so by splitting it, the first idea was let's just remove them. So from version 2 on, it was not part of the library anymore, and it will not become part of the core library anyhow. So it's a separate repository, and several people are working on this. Stefan, Tom, others also joining this, and the idea is to have the basic code for certain types of, for instance, sensors. So you have the geospatial sensor. These are certain types of sensors. These are implemented here. The same goes for, what do we have here? I/O expanders, for instance. So you have different types of I/O expanders. Inputs also, a rotary input. Hats is like you have the Raspberry hat, the Sense hat, the Elcrow, the CrowPi. So all different type of drivers or components are here, like a character display. So this is the 2 rows 16 display that I showed you before on the CrowPi, but we also have different types, like on the CrowPi we have an LED matrix, and there are all different types of drivers. So the idea is, for instance, your driver for your temperature sensor could become part of this, and then
Absolutely, yes.
we'll make it a
Sounds
lot
like it.
easier.
And
Yeah.
yeah, maybe as a like a thought that came to my mind, that maybe this could be a multi-model project. If some of these drivers grow a bit larger, then they could fit into it better as a separate module. So this might otherwise
indeed.
grow too big again.
Yeah, it's
and
actually
too many dependencies.
It's all source code. It means it's all just Java code, so there's no C complicated stuff in here. So that's the simple thing. What the people who are working on this also try to do is really separate things. So don't mix code from different types of devices. Don't mix them so that it becomes completely impossible again to maintain it. So that's a bit of a concern for this, but they're actually working on this. So also
you need to remind me also that I will contribute that Pioneer 600 board, because that's basically going to the hack package.
For now, it's only 4 contributors. Actually, Tom is not in this list, but Tom has been working a lot on another repository. I always mess up the name. I have to check in the repositories itself. Tom Aerts is a retired engineer. Here is he, and he has been working on this, which is, this was really example implementations, and now we are taking some of these out to really become drivers. And then this project will show you how to use these drivers. So that we have both just a driver implementation for the people who want to dive into the details. How do I talk to this device? And then examples, how do I use these drivers? How can I build an application on top of it? So that's something which will happen here. So these are very coupled together. You see there are also a lot of contributors here. Actually, Pi4J is alive and kicking, as they call it, because I want to show you 2 important things. Is the team. So Robert Savage is the founder of it. He started it. He's no longer active in the project, but then you have a long list of people who are, let's say, in the core. They really contributed big parts of the code. But if you look into the sources, again, if you go to Pi4J, the main library, then you see that we have over 25 people who contributed 1 or more changes or improvements or bug fixes. What happens quite regularly is that people find a bug and apply a fix themselves, so that they really dive into, why do I miss something here? Or because, and that's quite a challenge with the Pi4J project, you talk to electronic components, so that means you cannot just create a unit test. It's really something you need to test towards a real thing.
Yeah, testing is the thing that I have found the most difficult as well. It's very hard to automate anything because you need to have the exact device system ready, like attached.
And that's something we also improved with version 4. Is we have now this basic setup that we hope that everyone who wants to join the project set up for himself. It's very cheap. It's just 2 sensors, and these sensors can work both as SPI as I2C, and then a bunch of wires. And we just test input-output by using a pin as an input pin and another one as an output pin, and then see if we get what we expect. And like, for instance, also with PWM, we toggle it at a very slow speed, 10 times, and then we expect that we have same 10 input changes on the other side. So stuff like that. So that's something we test with this approach, and that's also part of the core project. So it's just a bunch of wires and that's it, and then these two sensors. So that's now something we found out, which makes it a lot easier to validate basic behavior of the Pi4J library. But that's another discussion. I hope to make a live stream about this and how you test the Pi4J. That would be really great. Tom advised me to buy a visualizer. How do you call it? To measure really the electronic signals. I forgot the name. It's behind me.
Yeah, the thing that makes those curves.
Those curves, those diagrams. It's waiting to be tested, but Tom is experienced in that, so I hope to do a live stream with him and then share it also how you use it. Okay, good. So this is more info about Pi4J. Now back to your project. So you used Quarkus. I have done a lot of experiments with Vaadin myself before. If you go to the Vaadin website to start a new project, by default, it uses Spring. There's very good integration within Spring. You chose to use Quarkus. Why?
Well, first of all, we have a very good integration to Quarkus as well. So even though the Spring is kind of our default stack that we use in the demos and examples, you can use Vaadin basically in Quarkus application in the same way as well. Certain parts of our tooling is not that well compatible with Quarkus, but to tell you the truth, I haven't been missing those parts too much myself. So we have a couple of very nice feature. For example, if you develop with a dual screen setup and you have a Spring Boot application, when you type in something and change in the view code, you can just move your view to the other screen and see the change there. See how it automatically goes to the browser, or the tooling in the browser detects the change and it reloads the view automatically. So that's why you see how it modifies. If you change the size of a button, or for example, then you see it immediately how it looks like there. That's a very, very nice setup. But implementing that on Quarkus stack has been, let's say, a bit complicated because of how Quarkus's own library load system works, and we haven't gotten that working yet. I think we have investigated that it should be possible these days, but it's just not there yet. So now with Quarkus, when I do and make a change in the UI, I need to move my focus to the browser, hit Command R to reload the page, or F5, and then I can see the change. But these are just like tiny problems there. But in the same way as for Spring, we support the dependency injection. So we have the CDI variant that Quarkus uses. We have full integration to that as well. So you can, for example, in this project, I have written basically all the hardware integration into a separate service that is totally detached from the Vaadin UI code. So then the code structure is much more cleaner, and then I'm just using injection to get that into the view, and then the view code is cleaner because there is no hardware integration on that part. And yeah, well, basically anything else, everything where you integrate into Quarkus. And actually, in the latest Vaadin 25 version, the Quarkus integration has gotten even better in some parts than in the Spring Boot. So if you use Vaadin with Spring Boot, you need to have a separate Maven plugin that we provide, Vaadin Maven plugin, because if you use some customizations to the front end, Vaadin needs to do kind of a custom front end bundle. So it's basically using npm and build tool, front end build tool called Pi4J behind the scenes, and then it rebuilds the JavaScript side of Vaadin automatically for you. But in Quarkus, you don't need this separate Maven plugin. You only need one dependency, and you can use that Quarkus tooling. Is it Quarkus X is it ext or extension add Vaadin, and then it suggests Vaadin, and then hit enter. Then you have that dependency, and then that dependency alone brings you just the Vaadin APIs and also this automatic front-end build system. So when you package Vaadin, it automatically goes through that. If it needs a custom front-end build, so it builds it, and then you have it there.
Oh, great.
So there is pretty much no difference. But one thing, especially for this tiny project where I'm using this Raspberry Pi Zero, is that with Quarkus, if you run it, especially on JVM, it uses a bit of less memory than a Spring Stack does. So they have done miracles on that side. So they have cut down everything that is not required, and that's why it uses bit less memory. And that might be critical in this case.
Yeah, you're running this on a Pi 02, so that's the one with half a gig of memory.
Yeah, so very, very minimal. Well, minimal. If I would start from scratch, I would probably not play around. I would get the Raspberry Pi 5, which I think the minimum amount of memory is 1 gig, which is then more than enough. 500 megabytes, that's enough, and it works. But with more memory, everything is faster, and also if you happen to get a lot of users. Well, for my barbecue smoker, there will probably be not too many smokers. Usually it will be only me, and maybe my television set will be broadcasting the thermometers view also for the main cabin. But otherwise, there is just like in maximum there is handful of users, and that's why the memory will be not an issue at all. But if there would be like hundreds of different users, then I would need 1 gigabyte of memory.
By the way,
because
I've run a Vaadin application on a Raspberry Pi 4 with 2 gigabytes at Devox with all the people in the room joining my demo, and I didn't see CPU going up, and memory was not an issue at all. So that's what Java is good at, is handling a big load. And then, tasks are getting created and threads and stuff like that. So it's really, most Raspberry Pis are more powerful than a basic EC2 instance on AWS. So
not the Zero one, but every other one is.
And I moved some Java apps that was testing from the original Zero, which also has half a gig, but a slower processor and only 32-bit system, to the 02, which is actually comparable to Raspberry Pi 4, I think, the CPU. And actually the speed improvement is immense if you compare the original Zero with the 02. But you only have half gig, so that's the limitation. But it's enough.
And the CPU in Raspberry Pi 5 is from a totally different planet, then so it's way faster. Even if the memory is not a problem, but I guess it's also like how it's not like raw CPU power alone, but how the memory bus works there, and also the other Raspberry Pi server that I have on my cabin is it has this kind of a SSD drive, and that makes it much faster as well.
Yeah, that's also a big difference. Just want to mention here on my website, Single Board Computers, one of my goals of 2026 is to compare more single board computers and how they can handle Java. And I've tested these. So this is the Orange Pi 5, which is very comparable to the Raspberry Pi 5, not only from form factor, but also from performance. If you look further into tests, so these are benchmarks from the how this is called, this project, Renaissance Suite. So these are wrapped in a JBank script to run them and then upload the results. So I've compared different boards. Actually, I should add the Raspberry Pi 02 here. I've not done that yet. But then you see that, there's a big difference between Raspberry Pi 4 and 5. I have to say that the RISC-V boards are way behind at this moment. but yeah, it's expected. It's an open source hardware board CPU. So, but they are also doing immense work to release new versions of these RISC-V processors. So I expect and hope to see this improve a lot.
Yeah. By the way, now that you have those boards there on, have you tried using these? Arduino has this kind of a combination board where they have both microcontroller and
not yet.
Yeah,
it
would be very good. Probably you can run Java there, and it would be quite interesting. And that has
it would be really interesting.
Cheap.
Yeah. To be honest, you see that stack of computers there on top of that screen. Those are all the boards I have. I have to be really honest. I don't spend any budget on this, so I really reach out to these companies. I want to do this. Please send me your board, and then I will compare them and create some videos and some results. I don't want to spend money. So I asked also on Arduino, can you send me some of these boards? And unfortunately didn't get that reply. So the call is still open if they send me some. So if I get bored and I have some time, then because also behind me, those little blue boxes is banana pies. They're already waiting a month to be tested. So I hope to add them soon. Okay. But back to your project. Another question I get asked a lot and already for many years is why don't you use native compiled Quarkus or whatever on Raspberry Pi? And I tried it several years ago, and then I got stuck on the fact that I needed to compile it on the Raspberry Pi itself and didn't have enough memory. Should be solved by now with the Raspberry Pi 5 with 16 gig.
Yeah.
You can, of course, compile it somewhere else, CI/CD, somewhere, GitHub Actions probably, and then
I think you can. I tested on my system, and you can use Pi4J if you happen to have a Mac. So then you can cross compile it for Raspberry Pi. But I would like that the system gets very complicated and fragile. So that has been kind of my main reason not to do it because it's a lot of work. And I don't really see the benefits of it because even this tiniest board has like enough memory for my needs. If I would be trying to host as many people as possible on a single server there, then maybe I would do the effort. But there is a lot of things that you lose if you go with CrawlVM. There is like reflection things that you need to typically configure whatever you have used in your libraries, and it's a lot of work, to be honest. And also especially when you are developing, then even on my MacBook, which is very powerful one, and it has 36 gigabytes of memory and the best possible CPU that is available, but even there the compilation is slow. It takes time, way more than if you do like a if you rebuild it with Maven for bytecode, and then when I need to deploy it, then with CrawlVM you get one binary. It's a big pile of bytes. So it's I think this one was something like 100 megabytes when I compile it. If I now make changes and I want to try it out on my actual hardware, which is basically the only place where I can test these hardware integrations, I need to re-upload it every time I make even tiniest change, the whole big 100 megabyte thing. But the way that I do it here, maybe I can actually show a demo about that. But here I'm using like the way how Quarkus is built by default. So it's basically exploded. So it's not a single jar file, but it's exploded. There is one runner jar file that is kind of kickstarting the application. Then all your dependencies are exploded there. And then when I create a new version of my application, I have an rsync script that detects that, okay, only this part changes. So that's my classes and everything else is the same. When I resync that to my server, it's just a couple of seconds. And then because it's this one is slow device, so it takes something like 15 seconds to start up. But on the Raspberry Pi 5, the new changes are there basically immediately. Even though it's only this older 2.4 gigahertz Wi-Fi.
And I love that, like you said, the Raspberry Pi 5 is a different beast. So I do a lot of Visual Studio Code development on the Raspberry Pi itself with GBang to test, for instance. That works perfectly. It's just like any other computer you would use. And yeah, indeed, you can just develop also on your PC and send a changed jar or compiled code to it and execute it. By the way, that's rsync-based deployments, boot to VM. That's also something that you shared. Is this some kind of tool to simplify your workflow?
Oh, yes. Yeah, let me show it to you. Yeah, this is a rather new script that I created, not only for Raspberry Pis, but also like couple of other development projects that I have been doing with Vaadin. And there I'm not using any kind of a special cloud service, but I basically have just a virtual machine. And there I just upload my jar file and restart the systemd service there. And this is basically a JBang script and nothing else. So it builds your Java application, supports Maven only at the moment, but it builds your Java application, and then you call it deploy, and then it uploads a new version. The init script here, this is the one that you need to execute on the first time. It asks you a couple of questions and how you want to configure it. If you want to add, for example, front proxy on top, it has caddy support there. Caddy is very handy as a reverse proxy. And if you want to enable HTTPS and so on, and on the subsequent deploys, it just deploy. Let me actually show it to you with this. Let's make some tiny change that we can see in the UI. This is from directory here. Let's open the main view. Let's add hello Frank. And now it's saved. So now I need to be in the right directory. So this is my Quarkus application directory, and now I call deploy. So this is the JBang script. It's installed. So now it builds the project, and then it synchronizes. Now it's using rsync to send it on this device, and in okay. This is now interesting. Of course, there is a demo effect.
Always in any live stream or conference talk or
what is let me check if my SSH smoker.local okay, it should be here.
Should be available, yeah.
Okay, it's deployed. Okay. So the actual the rsync itself, that was very fast, but it was this another command. So when you actually restart the Quarkus application, because it's this tiny Raspberry Pi Zero, it takes a lot of time. So that was the 15 seconds delay. But I have been working on my second Raspberry Pi project that is taking photos of the sunsets from that Raspberry Pi 5 device, and there the restart is basically instantaneous. So it takes like a second and a half to restart the server. So there the actual upload might take longer even.
Okay. Can we now see that it's changed on the side?
Oh yeah.
Now you have to prove that it worked.
I wanted to show another thing about this as well. So this is now using the same place. It's actually exposed with what is it called? Cloudflare tunnel. So that's what I use to expose this from my internal network to interweb. And here you can see that there is hello Frank here available. So this is quite handy, and this is now running in a simulator on my Mac, but I wanted to show how I use it on my mobile phone as well. So that's very essential, especially if I go for a fishing trip. I don't want to take my laptop there, and I want to still kind of control the smoking. So the best way is to use so-called progressive web applications. So you need to find this share dialog if you are an iOS device. On Android, Android actually suggests that do you want to install this. And here you add it to your home screen, and then there is a icon that is generated by Vaadin, and then it adds the address there. And now if I open it from here, from this icon, it actually opens the application full screen. The first reload takes a bit of time because it cases all the client-side requests, but now it doesn't have the location bar at all from the browser, but all the screen estate is reserved for the actual Smoker application. And then the same thing, I can control it here. Yes, it's changing, and yeah, touch support and everything.
I hear the servo turning around.
Okay.
We have a few more minutes. You were talking about the sunset project. Is that something you can show, or is that for the next stream?
I can. I wonder if my camera is still connected.
Yes, it is.
Oh yes, yeah. So it is this server here. So this is Raspberry Pi 5. I actually run this project earlier also with a Zero device, another Zero device. But when I was rendering the videos, it became very slow. So that's why I bought a faster one. And this now has SSD as well. So there is plenty of room. And this is the Raspberry Pi camera that is hanging currently here. But I actually have like a waterproof box here, where I am planning to install it, and then it's going to be placed on the jetty right there, and then I will be able to take the photos. But let me close the camera and show it to you from the browser. So if you go to jetty.this address, so this is that server. So now you can see the same photo that you saw from my iPhone, and if you go to the camera view, you can actually make a photo. So if I put my hand somewhere here and create a photo, I can see my hand. And yeah. For this, I created in the same way as with the Smoker project. So I created a new library. So the Raspberry Pi or Pi4J doesn't support cameras directly because it's actually not that much related in the Raspberry Pis itself. It's more for the lib camera integration. So that is basically providing a Java API on top of the lib camera C library, and then I can write this in a similar way. So this is also a Quarkus application that is then using this lib camera 4J integration, and then I can create time-lapse videos. So here I can configure that where I want to, if I want to have something. Let's take from morning to noon and generate one. So this is now it's executing FFmpeg on the actual device. So I didn't make a Java version of FFmpeg because it was way too hard to get the hardware acceleration for video generation. So
and FFmpeg is in all the video software. It's amazing tool. Yeah, but you're right. People already asked before, do we have some kind of camera support in Pi4J? No, because we focus on those GPIOs, and the camera port is actually another type of port. But yeah, we have now your library, and you proposed already some time ago, maybe you can move it to Pi4J. We'll see about that. It's still open.
Probably in the Pi4J project, it might make sense to kind of show all. So the examples, even though it is using some other libraries. So here you can see this is from today. It's not always sunshine. So in the morning it was quite misty, and now it's turning lighter and so on. I should have used a bit faster bitrate for this video. It's better if you use just like a couple of second video, and then it looks better.
But again, a nice example of how you use dedicated hardware with existing knowledge of Java and creating user interfaces, and then calling a great tool like FFmpeg. So yeah, it's amazing how you can use Java to glue everything together, and then use Vaadin on top of it to build a nice user interface.
Yeah, and the other system that I have here is related to my fishing hobby as well.
The water level.
So I want to see the water level in the Baltic Sea. We don't have like tides, so but the water level actually changes quite a lot still. So if there is like a high pressure air here, then the water goes away, and then there are currents in the sea, and that affects quite a lot on how different fish is active. And I have had this hobby project called Catch a Fish. So this is basically fishing diary that I have built. This is run in a real cloud, and here I'm following the weather, and I'm using kind of I have like a weather service which is hooked on the jetty, and I'm getting all that data, so I can see the air temperature, the water temperature, and of course the sauna temperature. That's not related too much to the fishing, but sauna is very important for the Finnish people. Yeah. So now my like final goal on this ongoing project is to get notifications from this system, so that it tells me that when it's well, it's always good time to go fishing, but as you can see from here, best, beautiful, yeah, but but I want to know if it actually makes sense to go fishing if you wanna catch a fish, and because these like commercial weather services or these stations that I have bought for this one, they don't report the sea water level. That's why I needed to create a custom device. So that's why the water level sensors. These are actually coming from another waterproof box, which is already on the jetty, and that contains a tiny little piece of ESP32 software, and that then sends the data from those sensors to that Raspberry Pi 5 device. And it actually has two different sensors. So it has a radar and ultrasonic sound sensor. And you can see them following pretty well each other.
Okay. Another example of someone who is automating his life way too much.
Yeah, this one got a bit out of hands, I have to agree.
And again, the main reason why you created this just because you can and it's fun.
Yes. Yeah, just because it's fun. Yeah.
Okay. Thanks a lot. Thanks for all the info. Please provide me all the links that we mentioned, quite a few, and we will add them to the show notes, to the description of this video. So people who are interested, I will also publish this video on the Pi4J website, and of course it will stay available on YouTube. Okay, that's a wrap for this live stream. I plan to do more about this version 4 of Pi4J and all the amazing things that you can do with it, and then also the drivers library once we release it. So stay tuned. Thank you so much, Matti, for joining me and sharing your experience and all your amazing experiments with Vaadin Quarkus, and how you can combine this with a Raspberry Pi hardware. If you want to check out Matti's deployment tool for getting a Vaadin and Quarkus app running on a Pi in about 10 seconds, the link will also be in the description. So Pi4J version 4 is now officially smoke tested, and the Vaadin UI is looking better every day. So please follow Matti on social media if he's still active there, but he's sharing things from time to time.
I'm very active still on the GitHub, so that's my main social media these days.
Yeah, that's also social media indeed. So he'll share his progress there. If you enjoyed this stream, then hit the like button and subscribe if you haven't done already before. Also, let me know in the comments, what would you like to control with the Raspberry Pi, or what are you already controlling with it? And Java, of course. Hope to see you in a next stream. Thanks for joining, and see you later.
Bye-bye.